Hello everyone, welcome to our pre-calculus pre-recording video. This is our lesson 4, understanding symmetry, testing for symmetry from equation. So in this lesson we will extend our idea from the previous lesson. We already discussed about how to understand symmetry from the given graph. So we will review that a bit in this lesson also, and we'll do some testing for symmetry from an equation. These are the agenda: symmetry review, testing for symmetry, equation 1, why do we care about symmetry, understanding symmetry, then testing for symmetry from an equation, and practice. So basically all of them are somewhat symmetry related. This lesson is mostly uh, inclined towards the symmetry from an equation. So that is the main part here. So let's start the reviewing first. This is the symmetry for X symmetry when we have the graph in the up and the down is same, just the reflection about the x-axis. Then it is X symmetry. Just you can think about a mirror at the x-axis. Okay, just think about a mirror. Just think it as a mirror. So if you have a mirror here, let's draw it. So this is somewhat like a mirror. Okay, when it is X symmetry, mirror is at X. Simple way to understand. When it is X symmetry, mirror is at X, and you will see the reflection about the x-axis. But you see, if you draw it at the y, you don't see the reflection because there is nothing here. There is nothing here, nothing here, nothing here. So you don't see it. That means it is not y-axis symmetry. But when it is y-axis symmetry, actually, then mirror is at y. Here is the mirror now. Then you see, you will see this thing in the mirror like this. In the mirror like this. Let's say if you have a person here, then you will see this guy in the other side of the mirror, right? And you can see it here. That means it is y symmetry. And when it is X symmetry, you will see this guy here in the opposite of the x-axis. The leg is down here. Leg will match with one another, something like this. And for the origin symmetry, corner will match. If this guy is here, then for the origin symmetry, there must be someone in the other part, in the other corner of the graph. Somewhat from the origin, you can think a mirror at the origin if you want to understand it as a thought experiment. So yeah, and how to test symmetry from an equation. So the rule is this: we will replace y by, for x-axis symmetry, we will replace y by minus y and check if the equation is same or not. Okay. So if we give a y by minus y, then is this equation is same with the previous original equation. Let me write another copy so that you understand it clearly. So this is y equals to minus 3x, then x squared plus 1. This is plus 3x. Let's remove this minus from here. So this is our original equation. Now for the first condition, for the x-axis symmetry, we replace y by minus y. So if we give a minus here for the y, is it same? Is it same with our actual equation? What does it mean? Let me show you all with another example, another easy example. Suppose you have just only y equal to x squared. Y equal to x squared. Just simple this one. Then if we replace, let's test this one. If we replace y equal to minus x, x as minus x, then what happens? Then minus x whole squared. Then you see it becomes minus x whole square means plus x squared. That means y equal to plus x squared. That means the equation uh, after the replacement, the equation and the actual equation is same. That means this equation y equal to x square, it has actually y symmetry, y axis symmetry, this one, because after this replacement still our equation is same. So this is what we mean by equation is same or not. Here in this case after this replacement equation is not same, there is a minus here, the equation is not same. That's why this equation, this given equation, this one, do not have x axis symmetry. Okay, now let's test if it has y axis symmetry. So let's test it. Now to test it, we will have to put a minus for the x by minus x. So let's take a thinner. So if we multiply this x by a minus, so there will be a minus here and there will be a minus here. So ultimately it will become, this will become minus thrice x, then x squared plus 1. And see, there is a minus here. There is a minus here after this replacement, extra minus. So that means it is also not matching. That means this equation do not have even y symmetry also, because it is not matching. Now let's check the third option. Does it has origin symmetry? So for the origin symmetry, we will have to replace both of them, both x and y. So let's do this replacement here also. So we will have to put a y minus here. Then this minus will be carried here because there is nothing else that we can do here. Now see, from the left and right hand side, we can eliminate this minus because there is an extra minus in the both sides. Or in other words, we can say that let's multiply both sides by a negative sign. Then we will get y equals to thrice x, then x squared plus 1. Then you see, this is actually matching. See, this is actually matching. They are the same. This one and this one is same. That means this equation only has origin symmetry. This one only has origin symmetry. Origin. Only this equation has origin symmetry. Origin. O is, this is the O. Okay, so this equation has origin symmetry only. This is how we can test it. We can replace y by minus y and check if it is same. Replace x by minus x, then check if it is same. Replace both of them and check if it is same after the calculation. If it is same, then it has that symmetry. Okay. Now let me show you a another approach by which you can test it. So y equals to, suppose, x squared. If we put x equals to, suppose if we put x equals to 1, so what do you get? When x equals to 1, y equals to what? Y equals to also 1. When x equals to 1, y equals to also 1. Now see, x value 1, y value also 1. Now if we replace y by minus y, what happens? So that means x value 1, y value now minus 1. What will happen in this equation? So if x value is 1, y value is minus 1, then it becomes minus 1 equals to 1 whole square. That means plus 1. So minus 1 equals to plus 1. It comes this. Notice what happens. Then for this one, it says x by minus x and y remains same. So that means x by minus x, that means minus 1, y remains same, that means y is 1. So if we put it, then what happens? See, this is actually plugging in value and checking it. We are testing here. You will notice something interesting will come here. So now it becomes minus 1 and 1. X value is minus 1, y value is 1. So y value is 1. We are putting everything here. y value minus 1, y value 1, x value minus 1. So x value minus 1 means minus 1 whole square, and it becomes 1. 1 equals to 1. Then if we replace both of them, then what happens? Minus 1 comma minus 1. Then it becomes minus 1, then minus 1 whole square. So ultimately it becomes plus 1. Now see which of these three lines are matching in the left hand side and the right hand side. Minus 1 cannot be equals to 1. They are not satisfying because we started with minus 1 and 1. This one is actually giving us the same answer. This middle one is actually giving us the same answer. Same answer. And it is actually satisfying this original equation. And same goes here. Minus 1 and minus 1. And basically we get here something different. So if we replace both of them, then it is not satisfying. If we replace only x by minus x, then it is fine. If we replace y value, then also it is not fine. So and this value, we started with this value, x goes to 1, and you can start with any value, 2, 3, 5, 10, minus 2, minus 1, whatever you want. You can start with a value, and you will notice this same pattern. Which of the symmetry it has, it will automatically give you. Okay, so this is the digital. By putting some value, this is another way to test it, but it may not work in some cases if the equation has too much complexities, something like this one, or if it has x divided by y type of thing, because then suppose y equal to 0, it becomes undefined. So basically all of a sudden some part will be undefined, so then it becomes difficult. For this equation we can test it. Suppose x equals to 1 we put here. If we put x equals to 1, then y equals to, we get 1.1. So in this question we get 1, x equals to 1, y equal to 1.5. If we put it, if we put 1 here, we get y equals to 1.5. So then for x-axis symmetry, we will have to replace y by minus y. That means y value give a minus here. Then in the next step give a x value minus, and the last step give both of them minus and check if it is matching or not. Like, is this a solution, is this a solution, or is this a solution? Which one is a solution, or which one is agreeing with our original equation? Okay, which one is agreeing? So let's put both of them. Let's put minus 1. Since we already know that this is origin symmetry, so at least let's check the origin symmetry part here, because other two we already know that they will not match. This will not match, and this will not match here. Okay, so if we put y equals to minus 1.5, this is y equals to minus 1.5. Let's put here minus 1.5, and x equals to minus 1. So if we put x equals to minus 1, this is minus 3 into minus 1, then divided by minus 1 whole square, then plus 1. So in the left hand side we cannot do anything because it is just a number, so there is no calculation we can do. Here we can do some calculation, so it becomes minus 3. Then minus 1 whole square means plus 1, plus 1 plus 1 means plus 2. So this is minus 3 by 2, that means minus 1.5. So see, this is satisfying. Minus 1.5 equals to minus 1.5. When you put this, it is satisfying, it is matching. Let me show you what is not matching. Let me show you just to prove that how they are different. Okay, suppose we put which one? So let's say first one we want to put. We put 1 in this side and 1.5 minus 1.5 in the other side. So if we put x equals to 1, y equals to minus 1.5. So let's put minus 1.5 here, y value, because y value is the second value, that's why 1 minus 1.5 equals to 3 into x value is 1 divided by 1 square plus 1. Already it is done here, actually already it is done here, but still I am just showing. Then 3 divided by 2. So 3 divided by 2 equals to 1.5. but it is saying minus 1.5 equals to plus 1.5, which is not which is impossible. So that means it is not satisfying, it is not matching. That means this combination is not working. Even this combination will not work, only the last combination will work. Okay, so this is a digital plugging of the values, or digital way of proving what type of symmetry it has. Now you can, if you want to ask me, sir, how do you get first of all this 1.5 and 1? This is just a random value. You choose a value for x. Suppose x equal to 1 we have chosen here. Then y equals to what? Y equals to come 1.5. Then you start checking with this combination. Three different combination for x symmetry what, for y symmetry what, for origin symmetry what. This one you choose. Instead of 1, you can choose 2, 3, 5, 10, whatever the number comes to your mind, even the negative numbers also, no problem. Still, it will give you the origin symmetry. For fun, if you have time, you can test. I mean, you can do that. Even if you don't have time, you can give a try at some point, just to prove if, just to see if the math is correct or not, or if to see the hidden beauty of math by using the different value, different approach, methods, etc. All right. So these are the in-class practice. We'll try to solve some maths from here during the class time. Now, why do we care about the symmetry? Why symmetry is so important, or even important? The one reason is this. Suppose you want to graph this equation, 9x squared equal to 4y equals to 36. This is the equation, and we are planning to graph it. Now, what type of symmetry this equation has? If you know it, then it actually helps in the graphing process. There is x square here, so that means if you replace x by minus x, it will remain same. There is x square here. That means this equation has y symmetry. This equation has y symmetry. Now, just take two values. If x equals to 0, y equals to 9. If y equals to 0, then x equals to 2. Because y equals to 0 here, then 36 divided by 9, that means 4. Square root of 4 means 2. Plus minus 2. Yeah. So, now, if you already know that this equation has y symmetry, then you know that if there is a point here, there must be another point here in the other side, because it has y symmetry. So to be y symmetric, there must be another point here, another point here. And once you know that there must be one point here, another point here, and just a single point on the y-axis, that means the graph is going through this direction. So we can draw the graph without any further calculation. As I said in some previous lesson, that sometimes without even plotting all the points, by analyzing and understanding more and more about the nature of the equation, we actually can draw it without even plugging in many points. Normally, to draw a curve, actually you need a lot of points, or else it will not make sense which direction it will go. But if we understand the symmetry and some few more, then actually step by step it helps to understand the graph more and to draw it more easily. So this is one way why do we care about the symmetry, and the ways it helps us to draw the graph easily. Let's look at another way for this. Is not another way, just another example of testing the symmetry, which I have already said a bit. Y equal to x squared, this one. So if we replace x by minus x, first of all y by minus y, what happens? Is it same? No, it's not same, because there is a minus here. There is no minus here. Then x by minus x, see, minus x whole square, so basically it becomes same. That means it has y symmetry. This equation has y symmetry. And this is not same, they are different. So I do not have origin symmetry. This equation do not have an origin symmetry. Now we can test all these equations from here also, what type of symmetry it will have. Just try to put this value and check what type of symmetry it has. Okay. Suppose if we want to test this one, if we put x equals to minus x, just like this one, suppose if we want to check y equals to minus y first here. So there is a y here, So if we write x equals to y by minus y, then whole square, then minus y whole square equal to actually plus y square. That means y equals to y square, x equals to y square. So this is actually satisfying as the as our actual equation. That means this equation has x symmetry. This equation has x symmetry. This is y equals to x cubed. X cubed. Check it what type of symmetry it has. It should have this. So if you want to check it, what type of symmetry it has, this one. First of all, replace x by minus x, then replace y by minus y, and then replace both of them. It should have origin symmetry only. Check it if it is same or not. This one also should have origin symmetry only. Now what about this one? This is tricky. If you replace x by minus x, equation remains same. If you replace y by minus y, equation remains same. If you replace x and y both together, still the equation remains same. Then what is going on here? Eh? What is going on here? Actually, this equation has all the symmetry. Then this equation, if you replace x by minus x, then what happens? Equation becomes different. Y by minus y, equation becomes different. Then both of them, still equation is different because there is a minus here, extra minus, there will be extra minus. That means this equation do not have any symmetry, no symmetry in this equation. Okay, no symmetry in this equation. So this way we can understand it. Yeah, you can try plugging in values also, just like our previous, as we said in the previous slides. So that way also it works, but the best way is always to check by using this method, because this method will work in all the situation. Okay, this is another example from application and extension part, what type of symmetry it has. So we can easily test it. If we replace x by minus x, there will be a negative here because there is no square here. Okay, so basically x by minus x is not working, so that means no y symmetry. Then y by minus y, we can put, there is a y square here, so basically x symmetry is here. And if you draw the graph, then you can see that this graph has actually x symmetry, not a y symmetry. Why x symmetry? Because you can replace y by minus y, since there is a whole square, then this minus y will become plus automatically because of this whole square. Okay, because of this whole square. So this way we can understand what type of symmetry. And origin symmetry will not have, because already we have tested there is a minus coming here in the x, extra minus, additional minus coming here for the x. So there will be no origin symmetry. So by analysis, actually we can already decide about that origin symmetry is not possible here, only x symmetry is possible, since we can only replace y by minus y and it remains the same due to the square. Okay, this is tricky. If you see anywhere is square, because the square will make this minus, it will make it plus, so basically it doesn't matter for the square. Okay, square can actually consume it, square can eat it, you know. That's why. This is also in class practice. We'll try to solve some maths from here, and this is the practice homeworks. Give a try to solve the maths, and these are just for practice, by the way. These are not your graded homework. We will give the graded homework in the Google Classroom, and that will come as an announcement. Actually, in the Google Classroom, you will see that formally we will give when it is a homework, graded homework. This is just for practice. If you can try to solve this math, and if you don't understand, you can ask during the class time. So that should, this is the way we can proceed with this. All right. So thank you all. Thank you very much. Have a good day, and see you all in the class. Bye bye.